In this video, we're going to take a look at a Leetcode problem called letter combinations of a phone number. So we're given a string containing digits from 2 to 9. Return all possible letter combinations that the number could represent. So return the answer in any order. A mapping of digit to letters, just like telephone buttons, is given below. So note that 1 does not map into any letters. You can see it's just a sign, right? It's not any represent any letters, but you can see 2 represents A, B, and C, right? 3 represents D, E, F, 4, and so on and so forth. And you can see that 0 is not representing anything, right? And then those symbols does not represent any letters as well. So we pretty much just have 2 to 9 for our combinations, right? So in this case, you can see here, we're given a digit in a string. So in this case, we have 23. This is our digits. And basically, we're just going to generate all the combinations that we can come up with, right? So you can see here, this example, we have 23, right? 2, in this case, 2 has A, has B, has C. 3 has D, has E, has F. So basically, we want to generate all the combinations. So we're going to have a D, a E, a F, B E, BD, BE, BF, CD, CE, and CF, right? So you can see that we have total of 9 combinations, right? And we want to return that in a list of string. Okay, so, and you can also see that we can have a empty. In this case, if I have a digit, in this case, the length of the string is empty, then pretty much we're going to have a empty list. And you can also see that if we have a situation where our current string, right, is only 1 digit, then we want to make sure that we get them all those digits that are all those letters that are related to this digit added onto our list, right? So how can we solve this problem? So this is a backtracking problem, and if you're interested to do more backtracking problems, I do have a playlist on my channel where I specifically talk about backtracking. And basically, to solve this problem, what we're going to do is we're going to use backtracking. And basically, we're going to start at the root level. We pretty much, for let's say we have a string, right? In this case, AB is 2, and this is 27, I believe. So yeah, 27. And basically, let's say we have those, let's say this is our digits, right? And what we're going to do is we're going to use backtracking, right, to do a DFS, iterating all those decisions that we have, right? And then do a DFS. Once we get our combination, we're going to backtrack, and then we're going to traverse to another path, right? So you can see here, we're starting at the root level, and you notice that on the root level, we have nothing on our string, right? And on our combination so far, we have nothing. So what we're going to do is that because the first character or the first letter or the first digit is 2, right? So in this case, 2 has 2 options. In this case, A and B, right? And there's also a C there, but I didn't do that. So in this case, we also have a C, right? There should be a C and something, something. Right? Okay, so basically, let's focus on this example, right? So if I have A here, in this case, 2 have A. So in this case, we can go down this path, right? We can also go down this path. We can also go down this path. But we're going to do a DFS to go down this path first. In this case, if I have digit 2, I have A, B, C, right? And then when we move on to the next digit, we have digit 7. And digit 7 has 4 options. In this case, we have P, we have Q, we have R, we have S, right? So what we're going to do is that we're going to iterate those options, and then we're going to do a DFS. In this case, currently our combination is A. We're going to do a DFS down this path, right? So now we have AP. In this case, if we have AP, right, this is one combination. And in this case, we're going to see if there's any other digits. In this case, there's none because we're on the digit 7. We're on the last digit. You can see 2, 7. We're on the last digit. So what we're going to do is we're going to add the current combination onto a list. In this case, we're going to have a list, a result list to keep track of all the combination. So we're going to add this combination onto our list, right? And then what we're going to do is we're going to backtrack. So when we backtrack, we basically want to reset. We kind of want to delete the the action, or yeah, delete the last action that we took. In this case, the last action that we took was to add this character, in this case P, right? So now what we're going to do is we're going to remove that character off of the off of our combination, and now we have back to A. Right now you can see we have an arrow back to A, and A we can go down this path. In this case we have a Q, right? In this case we add Q onto our combination, so we have AQ. And now because we're on the last digit and there's no more digits left for us to traverse, we're going to add the current combination onto our combination list, right? And then we're going to backtrack again, resolve or restore or delete the last action that we took was to add Q onto our combination, right? So now we remove Q off of our combination, and then we can go down this path. So we have AR, right? We add R, append R onto our combination, and then we know that there's no more digits left, so we're going to add AR onto our combination, right? So we have AR, we add it onto our combination. And then we backtrack, we restore the last action that we took, right? So to backtrack, we have to restore the last action we took, and then we're now back to A, and then we're going to add the next character, in this case S, right? So now we add S onto our combination. AS, we're going to add AS onto our string, right? Or sorry, our combination list, and then we're going to restore the previous the previous action that we took was to add S, and now we back to the root. And then once we're done traversing all the options, we're going to also restore the last option that we took, and now we're back to empty, and then we're going to go down to this path right here, right? And at the end, you can see we're basically traversing, doing DFS to all the path, and then to backtrack, we have to restore the last action that we took, and then at the end, we're going back to the root, right? So now you know how we can do this. Let's take a look at how we can do this in code. So to do this in code, basically what I did here is I have a table, a character, right, a digit that has corresponds to a couple letters, right? In this case, digit 2 correspond to ABC, digit 3 correspond to DEF, right? So in this case, what we also going to do is we're also going to have an array, right? This character array is equal to digits.to character array. And then we also have a result list that basically keep track of all the combinations that we have. So what we're going to do is you can also use a string builder. You don't have to use a stack, but in this case, to use a string builder, right? In this case, if I want to delete the last character, it's pretty much a linear time complexity. But if we use a stack, we can be able to pop the top element off of the stack, and this will give us a constant time complexity, right? So what we're going to do here is we're going to pass this stack into this helper function, right? And this stack is going to keep track of our current combination. So we're basically going to start at index 0, right? Just like here, we're going to traversing all the options for this current index, for this current digit. So when we pass it down to this helper function, we're going to have a check to see if the current index is out of bound or if we have no more digits left to traverse, right? In this case, if that's the case, then we're just going to add the current combination onto our result, right? Onto our result list. And you can see here we have a function that basically convert the stack to a string. And then what we're going to do then is we're going to do a DFS, right? So if we're not, if we still have, if this index is still within the boundary, then we're going to do a DFS for all the decisions, right? In this case, we're going to have a current string. In this case, this current string is basically correspond to the current digit, right? We iterate the current string, and then we're going to first add this character onto our stack, right? So and then we're going to do a DFS. Then we're going to restore the previous action that we took, so that for the next iteration, we can add a new character, the other character, right? In this case, just like here, I add a P in this case, and then do a DFS down to this path. And then when I come back, I want to remove P so that I can go down this path. And then doing the same thing over and over again until I getting all the characters that we have in our string, right? And then at the end, we're going to back to the root level, right? Because in this case, we're going to keep traversing all the options. Once we're done, we back to the root level, and then we're going to return the result, right? In this case, the result is the list that we're going to that caps all the combinations that we have, right? And this is basically how we solve the problem.